Hi, my name is Aditya Kota, and today I will be explaining the triangle congruency theorems. What are triangle congruency theorems? A triangle congruence theorem is a theorem in math that proves that two triangles are congruent based off of their sides and angles if they are congruent. Also, if two triangles are congruent, that means that all of their angles and sides are congruent too. If you just prove that the two triangles are congruent. It can also solve a triangle in certain cases, prove that the provided and or non-provided angles are congruent, and prove that the two triangles are not congruent. First off is the SSS theorem, which is the side. This theorem states that if all the sides of a triangle are congruent to all the sides of another triangle, then both the triangles are congruent. And read the note right here. So this is one example right here. So as you could see, this corresponding one to this one, and then this last one to this last one. So here's an example down here. Here's a question. I'll give you 5 seconds to answer it. And you're supposed to find out if they are congruent by the SSS or not. Okay, time's up, and the answer is they are not congruent, and they are actually similar, but they're not congruent. So good job if you got that right. Next is the SAS, which is the side angle side theorem. This theorem states that if in two triangles, the side and another side plus the included angle are congruent with the corresponding side, other side, and included angle, then both the triangles are congruent. So this is an example. As you can see, there's one side, another side, and they're congruent to each other, plus the included angle and the included angle, which proves that these two are congruent. Now here's my question. Can you prove that these two triangles are congruent down here? I'll give you 5 seconds, and you have to use the SAS theorem. If you got yes, then you are correct, because this long side is congruent to this long side, and they are corresponding. CB is congruent to ZY, and they're corresponding to, plus also the included angle are also congruent. Next is the ASA, angle side angle theorem. In this theorem, if two angles of a triangle and their included side are congruent to the corresponding two angles and the side of another triangle, the triangles are congruent. So there's this angle right here, and then angle C and angle B, and the corresponding angles are Q and R, and they are congruent. And the included side is CB and R2, and they are also congruent. So that means that these two triangles are congruent. Can you see if these two triangles are congruent by the ASA theorem in the highlighted box? I'll give you 5 seconds. Okay, time's up, and if you got yes, that is correct too, because C and F are corresponding and the angles are congruent. E and B are also corresponding and the angles are congruent, and the included side, CB and FE, are congruent. So that means all three are congruent in the right order. Next is AAS. So this one states that if two angles of a triangle and their non-included side are congruent to the corresponding two angles and side of another triangle, the triangles are congruent. So in this example, there's this angle right here congruent to this angle, this one right here, and this one, and then the not included side, which is not this long one at the bottom, but the side one over here, and those two are congruent. So ASA. Can you figure out if the two triangles in the highlighted box are congruent with the AAS theorem? I'll give you 5 seconds. If you got yes, then that is correct, because if you can see here, B is congruent to E, C is congruent to F, the angles, and then AB is congruent to DE, and that's AAS. Lastly is hypotenuse and leg, which is HL. This theorem only applies to right angles. So if it's not a right angle, this theorem is automatically one that you can't solve the triangle by. And it happens if the leg of a right triangle and the hypotenuse of a right triangle are congruent to the corresponding leg and hypotenuse of a different triangle. So over here, we see that AB is congruent to ED, and same with the hypotenuse. So CA and FE. And so that's HL because hypotenuse leg. So can you figure out if the two triangles in the highlighted box are congruent due to the HL theorem? I'll give you 5 seconds. Good job if you got yes, because as you can see, this leg is congruent to this leg, and the hypotenuses are also congruent, and they give us that it's a right triangle, so it is congruent due to the HL theorem. Thank you for watching.